Hi students, today I am going to explain test for significance. Already we did the video what are significant figures and how to test the errors, and now we are testing the significant figures. So what is the test for significance? In analytical chemistry we developed so many new methods of analysis and we have to know whether it is correct or not. So we desire to compare these results with the standard methods or accepted methods. So we want to compare these new methods with the accepted methods. So that is test for significance. So the average values from these two methods may have difference. So when we take the average of values from these two methods, what is the two methods? The new method which we developed in analytical chemistry, or the standard method which is already there and approved. So there will be a difference between these two methods. So why this difference occurs? This difference occurs because maybe indeterminate errors or random errors. We cannot determine the errors. It randomly occurred. So it may be due to indeterminate errors or random errors or systemic errors. So because of the systemic errors, also systemic errors or determinate errors, we can find out what is the cause for the errors and we can rectify it. So what type of errors are occurring, and so how we can minimize it, or we can do is there is a method for finding out of that is nothing but a null hypothesis. What is null means? Zero, we know, or no, nothing is there. So nothing, what is nothing? So nothing error is occurred significantly. So the method called a null hypothesis is the method used to find out the significance, test for the significance. So it considers no significant difference between the two sets. If it is null hypothesis is valid, means there is no significant difference between the two values, means the new method and the accepted method. So to test for the significance, we should know the standard deviation. So how much it can deviate, what is the level range of deviation of these two. So there are three tests for significance. Importantly, t-test or student's t-test, we can tell, or f-test and the chi-square test. First we will see what is t-test. T-test, it is used to test the null hypothesis that two means do not differ significantly. So we will take the mean of our one method which we are using, new method, and also the mean of the accepted methods. The two means how it will differ. So they will not differ that much significantly than the accepted. We can accept the null hypothesis. For this, the formula is t is equal to plus or minus, it may be. So x minus mu into root n by s. So here what is x? Average value for the finite series minus population mean, number of measurements, and s is standard deviation. So x is the average value of finite series which we are doing the mean is this one, x minus, this is a population mean, and the standard method the mean which it is calculated. So x minus mu. So all the population, its mean we take. Root n is the number of measurements we are taking, and it is the standard deviation. So t is equal to x minus mu into root n by s. So then after finding the t value, so that is nothing but t calculated value. So what we found is t calculated value, and but also we have t tabular value also. So we have to compare these two. So if the t calculated value is very less than t tabular value, then we can say the null hypothesis is valid and there is no significant difference between x and mu. So I already told x is the mean which we calculated and mu is the population mean. So there is no significant difference between them. So we can accept this new method. So and the variation which is occurred, it is due to maybe random errors or indeterminate errors. There is no systematic errors present in this. If the t calculated is more than the t tabular, then we can say this null hypothesis is incorrect. There is significant difference between x and mu, and the error is caused because of the systematic error. So when we are doing, some errors are occurred because of the systematic determinate errors. So we can conclude like this. And so it is concluded that 99% probability level of null hypothesis is valid. Means whenever we do this t-test, 99% there is a probability that we can say that null hypothesis is valid. So we'll get t calculated is less than t tabular value. So 99% this only the result. Then we'll see next is what is F test. It shows whether the precision of two different methods is same within the probability limit. So we are here taking precision. So two different methods, the precision is same or not. Okay, in the t-test the means are same or not. In the F-test precisions are same or not. So we compare this in terms of variance ratio. So F is equal to variance V1 by V2 or S1 square by S2 square. So always we should take S1 square is greater than S2 square. So always we'll get more than 1. So, and when we calculate like this, we will get the F value, that is calculated value. Same like t-test only. Again, we take tabular value and we compare it. If the t calculated value is less than t tabular value, so there is no significant difference between S1 and S2. So, null hypothesis is valid. Same like t-test. And if it is more than tabular value, if F calculated is more than F tabular value, so S2 is significantly greater than S1, so null hypothesis is not valid. So like this we can do. Then next is chi-square test. It is applied to study the behavior of data if the theoretical behavior can be expressed quantitatively in terms of expected frequencies. Here we will take frequencies. We will expect some frequency and we compare it with the observed frequency. So what is that observed frequency? Theoretical behavior here told. So whatever is the data we take, we observe some frequency and this is compared with the expected frequency. How much frequency we want, expected frequency. So in this test, it is believed that why these fluctuations or deviations are happening are because of the number bias. So if some are observing the observing, they may get some numerical value, others may get other numerical value. So there will be differences in the noting of the numbers. So there will be a number bias. So bias means errors. So in writing the numbers, in observing the numbers, there will be a change difference. So here the main they are telling is, they are explaining is fluctuation is due to number bias. So this test will give the comparison of number of frequency distribution. I already told frequencies with expected frequency, observed frequency will take. So chi-square, that is nothing but C square is equal to Fi observed frequency minus Fi capital Fi expected frequency square by into 2 by Fi. So like this we can calculate. We will get the calculated frequency size, calculated chi-square calculated, and it compare with the tabulated value. If it is less, calculated value is less than the tabular value, so no number bias is occurring. All got the same values. Yes, no, they observed the same values and fluctuation may be by chance. If it is more than the tabular value, so number bias is there. So like this, these are the 3 tests for significance. It is very important, and 3 are similar. Yes, no. So we just have to understand what is null hypothesis and we can easily write it. But formulas we should remember. We just go to the formulas. T is equal to x minus mu root n by s. Remember, T is mean, x mu. Yes, no. For F, variance V1 by V2 or S1 square by S2 square. And the third one, chi-square, is frequency. Okay. So this much if we remember, we can easily write it. Thank you.